Welcome back. We're still doing linear equations. Today we are solving simultaneous linear equations by substitution and elimination methods. Our objective is to be able to solve simultaneous linear equations by substitution and elimination methods, and you'll be successful if you can solve these simultaneous linear equations using both methods, substitution and elimination. You need to know both, and you need to know them manually as well as using it. And what I'll do, we'll start by introducing it a little bit from the book, then we'll go outside of the book and we'll continue. Okay, so for simultaneous equations, really we are talking about the solution for two lines, and it's exactly a point where they meet if there is a solution. An example is seen here. Okay, so if you look here, this is one line and that's another line, and this is where they meet here. Okay, now these two lines have the equation that we see here. So one is 2x minus y equals 4, and the other one is x plus 2y equals minus 3. Remember that an equation can be written in two ways. One is in the format y equals mx plus c, and the other one is just ax plus b equals c, and both of them are correct. So if we look at, for example, this 2x minus y equals 4, this is the same as if we rearrange them, y equals 2x minus 4. So we can write it in either format. So we're writing it now in the alternate form, which is ax plus b equals c. So we've got 2x minus y equals 4 and x plus 2y equals negative 3. If they do meet, they meet in only one point, which is the one here in this example. And at exactly that point, this point belongs on the line with the equation. This is x plus 2y equals negative 3, and on the line with the equation 2x minus y equals 4. So that point belongs on both equations, and it's only true at that point that it is true for both lines and belongs to both lines. So in reality, this point here that has x equals 1 and y equals negative 2, this is like we can call it x0, y0. This is the point that both of them meet. So when we are solving algebraically, we're really solving for that x0, y0, and x0, y0. This is solving looking for that single point. So since it's the same x and the same y, then we can manipulate it in any way we want. So substitution means just you find one variable in terms of the other. So you find x in terms of y or y in terms of x from one equation, and you substitute into the other. You end up with just one equation with one variable. So the equation has only single variable. You went from two variables to one variable. Then you solve it, you find that variable. So from that, you substitute into one of the equations, you get the other one. Because now this example became known, then you only have the other one as the unknown. You find it, and that's it. You then substitute back to verify that you make a mistake, and that's it. But the whole purpose that we can do that is because we are talking about the same point. So this equation is true for it, and that equation is true for it. It's same x and y we're finding, and the solution for it, as you see, is a single point. And indeed, in this example, when they found x equal 1 and y equal negative 2, the same as here. So whether you do it graphically or algebraically, and whether you do it by substitution or elimination, elimination is simply put we just go to the next page. Elimination, simply put, is you try to manipulate them so that if it's not already like that, the multiplier for one of the variable is the same. So if you wanted to get rid of the x and get y, then you multiply this equation by 2. Then you end up with 2x plus 4y equals minus 6. Now we've got 2x here and 2x there. Then you subtract one equation from the other. The x's disappear. You're left with the y's, and you find the value for y. Then you substitute one of the equations and get the x. So this is going through it quickly. Now I'm going to do exercises from outside of the textbook, and I'll do 3 different types of exercises, and that will allow you to do nearly every type of simultaneous equations. And also I'll be showing you how to use the calculator after each example. So example 1, 2, and 3. After example 1 and 2, I'll show you the solution for them, same solution. Well, first you see it algebraically using elimination and substitution, then you see it using the case calculator. So that we're done for exercise 1 and exercise 2, and when we get to exercise 3, I'll be explaining what we're doing with that one. Now, also with simultaneous equations, the other extension is when you are given word problems and you are asked from the words to come up with the equations, then solve. Now, let us go and do the exercises. Okay, so let's start. So we are given the following pair of simultaneous equations: x minus 2y equals 6 and x plus 6y equals 10. Now we are asked to do it by substitution and elimination. Substitution, simply put, is just put in using one of the equations. So this is equation 1, and that's equation 2. So we can use either equation to get one variable in terms of the other and then substitute another equation. So if we look, the very first step that we do, if you noticed, is we put the equations over each other like this. So we were given these equations, we always put them over each other like this, and you will see how that's important as we go. So we say substitute, say equation 1 gives us x minus 2y equals 6. So x equals 6 plus 2y. We just add 2y to both sides. So 2y minus 2y cancels out, and we are left with 6 plus 2y. So already we got one in the term of the other. So then equation 2 will give us, so substitute 1 in 2 will give us 6 plus 2y. So put brackets so we know that this is that entity. Then we have 6 from before equals 10, which means 2y plus 6y is 8y, and this is 6. So 8y plus 6 equals 10, which means y equals 10 minus 6 is 4. It's 4 over 8, which is simplified by 4, a half. So y equals half. If we call that equation number 3. So this is now already, we got one of them. We need now to substitute to get the other. So we say substitute 3 into 1. It gives us x minus 2 times half equals 6. Well, 2 and 2 cancel out. So x minus 1 equals 6, means x equals 6 plus 1 equals 7. And the last step is to verify. So verify or check, substitute, call that 4, substitute the values 3 and 4 into 1, we get x equals 7 minus 2 times half, this is the left hand side, equals 7 minus 1 equals 6, which is indeed what the right hand side equals to. So the left hand side, so indeed the left hand side equals the right hand side. So indeed this is our solution. For elimination now, for elimination it is the same process. So you've got now the equations in this format, and elimination just means trying to get rid of one of the variables, and that would be by looking at the multiplier and then trying to get the same multiplier to appear in both places, and if they have the same sign you subtract one from the other, if they have opposite sign you just add them, so x minus x cancel out. So this is the easiest because x have the same multiplier. So this is equation 1, and that's equation 2. Now we can subtract 1 from 2 or 2 from 1, but it's easier to subtract 1 from 2 because then it will be positive and we won't get an extra step. That gives us x minus x cancel out, 6y plus 2y is 8y. If we did the opposite, if we did 1 minus 2, we'll end up with minus 8y, and there's an extra step of getting that with positive. 10 minus 6 is 4, therefore y equals 4 divided by 8, which is half, exactly the same as before. So we can call that equation 3. Now substitute 3 into 1, we get x minus 2 times half equals 6. Therefore 2 times half is 1, so x minus 1 equals 6, so x equals 6 plus 1 equals 7. So if you compare, it is exactly like before. We got the same answer. Both elimination and substitution will give you the same answer. Now verify, substitute 3 and 4 into 1. You can substitute into either. That gives us, for the right hand side, this is right hand side and this is the right hand side. Right hand side is 6, left hand side, so we've got the right hand side equals 6, left hand side equals, it's independent of x or y, so right hand side is 6, left hand side is x is 7 minus 2 times half equals 7 minus 1 equals 6 equals the right hand side. So indeed this is a solution. So as you see, with substitution you just get one variable in terms of the other. You substitute in the other equation, you get one of the variable, then you substitute back and get the second variable. With elimination, you try to get rid of one of the variables. Now here straight away, you know, it's easier to get rid of the x. Otherwise, for the y's, we could have used the y's, and here you just multiply the minus 2y by 3, so you multiply the whole equation, so it becomes 3x minus 6y equals 18. Then you can eliminate the y's, but then that will involve an extra step. It's easier just to use the x. Now I'll just show you also, had we substituted 3 and 4 into the second equation, that would give us, well, x equals 7. 7 plus 6 times half This is the left hand side, equals 7 plus 3 equals 10, which is indeed what the right hand side in equation 2 is. So you see here, so that shows you that doesn't matter which way you substitute in, it's fine. You are verifying that you've done the correct method and you don't make any mistakes while calculating. Okay, so now I'm going to show you how to solve exercise 1 by the calculator. So these are the equations here: x minus 2y, x minus 2y equals 6, and x plus 6y equals 10. We're solving for x and y. Now I put it here so I have the equations in front of me, and I'll do it for you again. What we need to do is remember our menu button is this, the tools. Then you go to algebra, solve systems of equations, and it is linear equations. So it will tell you how many equations. We've got 2, because in simultaneous equations you can have any number of equations. You can have, if you think of lines, you can have 5 lines going through the same point, or 10, or a million, or etc. infinite. Number of equations, we have 2. The variables are x and y. Okay, so it tells us, alright, tell us what it is. So we can use that. We say, okay, it is x minus 2 times y at the top equals 6. So equals 6, that's the first one. The second equation is x plus 6y. So you can put 6y, but it's better for you to get into the habit of putting 6 times y. And it's extremely important when you don't have numbers but letters. But anyway, this is another way you can do it. 6y equals 10, and it by itself will put, when you finish, it will change it to 6 times y. So if we say enter, as you see here, it actually put this dot symbol, means it recognizes its multiplication. So I did it for you. And that's it. The solution was 7.5. So x equals 7 and y equals half, exactly like what we got in algebra. Okay, now let's do the second one. I'll also go and get the equation ready, and then we'll continue. Alright, so this is the first type, which is, that's straightforward. We'll move on now to one that's a bit harder, just a little bit harder, and then we'll continue. Okay, now let's do the substitution method. So 2x minus 3y equals -5. That's equation 1 and that's equation 2. Now, for substitution, it doesn't really matter whether the y's and x's have similar multiplier or not. It just works. So probably it's the easier in such situations. So we can get 1 gives us, or 2 gives us. If we say 1 gives us, it will actually involve dividing. If you get 2 it gives us, that's actually easier. Straight away will give us x equals 8 minus 2y. While if you use the first one, then you need to divide by 2. So x equals 8 minus 3y, and we'll call this equation 3. Okay, now substitute 3 into 1 will give us 2 times 8 minus 2y. So 2 times 8 is 16. 2 times 2 is minus 4y minus 3y equals -5. So now minus 4y minus 2y is minus 7y, and if we take them to the other side, that becomes minus 7y equals minus 21. So y equals minus 21 over minus 7, which is the same as 21 over 7, which is 3. And we call that equation 4. Now substitute 4 into 2 would give us that x plus 2 times 3 is 6 equals 8. Therefore x equals 8 minus 6 equals 2. So we got exactly the same method, and as you see here, substitution is actually a bit easier and has less steps in this particular instance than elimination. Now for verification, it's exactly the same as we did before. Let's call this equation 5. So substitute 4 and 5 into, it can be 1 or 2. So we used 1 in the elimination, let's use 2 here. So we'll say 2. It will give us 2 plus 6, this is the left hand side, equals 8, which is indeed what the right hand side is. So again, that's correct. Now, as you've seen here, we did examples where first we started where you didn't need to do any manipulation, especially for elimination. And there's this example you did need to do some manipulation, multiplying by 2 before you can continue. Now, you may be asking yourself, where did the elimination calculation come from? When I was doing the presentation, I actually decided to do elimination first, then did substitution, and then I realized later on that the technology did not record the elimination part. So let's go through it. Okay, so we've got 2x minus 3y equals negative 5 and x plus 2y equals 8. So if we examine it, the x's coordinates, the x's multiplier and the y's multipliers are not the same. Okay, so what we need to do is to manipulate one of them to get the same as this. Now, luckily, if you multiply this equation, we only need to multiply x by 2 to get the same as there. While if we wanted to use the y's, then we will need to multiply the 3 by the 2 and the 2 by the 3 to get 6y for both, which means multiplying the whole equation. So equation 1 will need to be multiplied by 2, so it becomes 4x and this minus 6y and this minus 10. And equation 2 multiplied by 3, then this becomes 3x plus 6y plus 24 equals 24. So luckily we don't need to do that. So we don't need to multiply both equations, because don't pick y, we pick x, and then we substitute, and we don't need to go through the longer process. So if you just notice that you only need a 2 to appear next to x, so multiply the whole equation by 2. So equation 2, multiply the whole thing by 2. 2 times x is 2x, 2 times 2y is 4y, and 2 times 8 is 16. Now we call this equation 3, and we rewrite equation 1, so this is 1 and 3. Subtract 1 from 3, so it's 3 minus 1, like we said before, so we skip one step, otherwise we have a negative and we multiply by 1 if we subtract 3 from 1. And that is equation we're talking about, not numbers. So, okay, we subtract equation 1 from 3, so it is 3 minus 1, equation 3 minus 1, so 2x minus 2x cancel out, 4y plus 3y, so this becomes positive, this becomes negative, and this becomes positive. So 4y plus 3y is 7y, the x's are gone, 16 plus 5 is 21. So 7y equals 21, which means y equals 21 divided by 7, which is 3. We call it equation 4. Substitute the value of y into the first equation, which is 2x minus 9. On the left hand side, we get 2x minus 3 times 3, which is 2x minus 9, equals negative 5. So we manipulate them and get them on the other side. Times 9 minus 5 is 4, so 2x equals 4, which means x equals 2. Now that we got x equals 2, we do exactly like we did before, and we call that, so we call this equation 5. Now substitute equation 4 and 5 into either 1 or 2. That would give us, let's see, the right hand side and left hand side. Left hand side equals 2x, so 2 times 2 is 4, minus 3y, 3 times 3 is 9, and that's equal negative 5, which indeed equals the right hand side. So that's correct. So as you see, this is elimination, and the above is substitution. It's fairly straightforward. We only gave extra explanations about the graphs and everything, so you would understand it. But once you are pressed for time, it's very simple and fairly mechanical. You go through the procedure and you get the answers, and then you substitute to make sure that you don't make mistakes, and that's it. Now I'll be showing you the same solution, how to solve it, same equations, simultaneous equation, how to solve them in the calculator. Now for the part of showing you how to graphically solve it, we have done this in previous video, where you draw the graphs and you go and find the intersection. It's one of the options in the graphing section. So we will not do this here. You can read your textbook and it shows you the procedure, and it should be just a reminder for you. So let's go ahead and find the case calculator and solve it and verify that we get the same answer. We go back. Alright, so exercise 2. Equation is 2x minus 3y equals negative 5, and x plus 2 equals 8. And again, the way we did it is solving equations. So equations it is to, so the first equation is 2x. We can do it from the keyboard also, or we can do it from the keyboard. 2x minus 3y equals negative 5, and the second one is x plus 2y equals 8. Enter. That's it. So that's how you solve them. And you can do the same for any other simultaneous equation sets. So I hope that you had fun, and as usual from your textbook, go and have a look. Now you can look at the example in the textbook, and for the actual exercises, I suggest you do as many as you can, especially the last few. Okay, so now we'll go to a third example, and that one I will not solve it for you. This is for you to solve. Now, what is different about this pair of equations compared to what we've seen so far? Look at it. If you look at the x's, one has x equals 2, and one has x equals 3. If we say, okay, that's fine, let's look at the y's. One has -3 and one has 7. So neither of the x's nor y's, you can't just multiply one of the equations for elimination and get it ready. You need to multiply both. Okay, so that's a big hint for you. What I'll be doing is I want you to actually try to solve it now and pause the video here, solve it, then come back and press continue or play, and then you get the solution. So the solution is this. Now you will know anyway if you did it right or wrong by substituting back, and you'll know if you made a mistake. This is just for checking. Okay. Now the last step we'll be doing, we have finished the algebra part. The last step we'll be doing is showing you how to solve using the calculator. Okay. We'll do the first and second exercise in the calculator so you get the idea of what's involved. Let's do that. Okay, now for the homework, you can go and do as many as you want, and don't forget when it shows you this simple example, for example, that this is similar to example 10, you go and watch example 10 and come back and do it if you're not confident how to do it. What I'm suggesting is do as many as you want, as long as you're not feeling competent or you're not feeling confident, and especially do the ones at the end. So test yourself with these. Okay, now for the last note on simultaneous equations, for lines we've got three different possibilities. Either the lines are parallel, so they never meet, so there's no solution, or they're not parallel and they do meet, there's a single point, or it's the same line, so it meets at every point, so you've got infinite solutions. So for example here, when we look at 2x plus y equals 5, this is actually the same equation multiplied by 2. So multiply this by 2, both sides by 2, this becomes 4x plus 2y equals 10. So it's actually the same line. Okay, so we can simplify as a matter of fact by 2 from each end becomes 2x plus y equals 5. It's the same line. We draw it over each other. It's actually meeting at every single point. And with this, we've got the theory covered for this chapter. And to recap, we have seen how to solve linear equations using substitution and elimination. We have seen how to solve using the CAS calculator. So we've done our objectives and we have successfully solved them. So we have met that criteria as well. And till we meet again, I bid you farewell.